Hey kids, welcome to a homework video for Eureka Math Grade 5, Module 1, Lesson 3. So here we go, and you can always kind of tell where I am. This is Module 1, this is Lesson 3, it's the homework page. I do have a video for the problem set for this lesson, and I would highly recommend that you go watch it before you get started on this homework page. It has a lot of really good notes, stuff like this, where I'm kind of explaining my way through what is an exponent, what's a base. I'm going to be talking about that in this lesson. Some examples, especially using 10. And so I'll talk about like a power of 10 or like 10 to the third power. So lots of stuff on the problem set video. You really should go watch it first. If you have already seen it and you've already had the lesson and now you're ready for homework, let's do this one. So here we go. Write the following in exponential form. So we have lots of different ways we can write numbers. Exponential form, for example, is taking this standard form and turning it into an exponent. You may not have known, but yes, you can write this in a different way. This still means 100. It's just showing what 10 times 10 would give you. So if this is the base, here we have it 2 times. Remember, exponents are not factors. These are not the numbers that we're multiplying by. It's just using the base that many times repeated. Okay? So as we get in, we need to write in exponential form. So we're taking the standard form and we're changing it to look like that. So what's really nice here is that we're using 10 as our base. So when we do that, how many zeros? So if you watch the problem set, you know all you have to do is count the zeros. So in exponential form, you're going to have 10 cubed because it would be 10 times 10 times 10. That's going to be 3 tens, not 3 times 10. 3 tens multiplied by each other. So 10 times 10 is 100, and then 100 times 10 is 1,000. That's why 10 to the third is equal to 1,000. So as long as you understand that, you can keep going. If you don't get it, please go watch the other video first. Here we have 10 twice, which means 10 is our base, and 2 is your exponent because they're telling you you've got 2 tens, so 2 of them multiplied by each other. The total of that would be 100, but they're not asking you to write the answer. They're just asking you to write this in a different way. Here, again, we get back to the base being a 10. And how many zeros? This is really the key because it's how many place value positions do we have to shift, but it really comes down to just counting. 1, 2, 3, 4, 5, exponent 5. What if I have all these different things? I can still use 10 as my base and count the zeros again. 2 zeros here and 1 here make a total of 3 zeros because 100 times 10 is 1,000. And 10 cubed is equal to 1,000, which we have proved over here. So again, it's all about counting the zeros. Look and count. 1 million is equal to 10 to the 6th power. 10,000 times 10, I have 1, 2, 3, 4, 5. 5 zeros. Look and count. Use 10 as your base. And whenever you have 10 or 10,000 or 100 or whatever, if they're all multiplied by other tens, hundreds, thousands, you can just use 10 as your base. Count the total number of zeros and you're done. Now here we have other factors involved. So it's not just 10 times 10, it's 4 times 10 cubed. So what I told my students is to write, let me straighten you out there, is to write, if you need to, if it helps you, how many zeros there would be so that you can then have an easy factor to multiply, which is going to be your 4, times the whole number. So for my students, I said, if you're not sure where you are, write it out. It's always good to show your work. So now if I have 4 times 1,000, I have 4 times 1, which is 4, and then I have the 3 zeros. We have to write our answers in standard form, which means just the number or like not with an exponent. This is standard form. Okay, so if you're going to move on and have 64 times 10 to the 4th, so 10 to the 4th is 1, 2, 3, 4 zeros. If it'll help you, you should put in a comma after every 3 places so that you can recognize where the periods are. Then you can see that 64 times 1 would give you 64. Then tack on all the zeros. Each one represents a place value position, so make sure you get them all. 1, 2, 3, 4. 1, 2, 3, 4. Now put your comma in, and you should end up with 640,000. Now for all these, we've had multiplication. All of a sudden, watch out, we have division. So what are we dividing by? Well, 10 squared. Write it out in standard form so that you can see how many shifts I will have. So it's 5,300 or 5,300 divided by 100. Now if you remember, the way that they do this is they're going to stack up the skills. And so in lesson 1, you learned how to multiply and divide by powers of 10 or 10, 100, or 1,000. So if this is division, I hope you remember you're going to shift these digits to the right to make them smaller. And how many shifts is going to be the number of zeros. So this is going to shift to smaller positions, so I end up with 53 as my answer. Same thing here. I've got division, so I'm shifting the digits to the right again. How many times? This time it'll be 3 times the 3 exponent tells you. So since I'm shifting this to smaller place value positions 3 times, what's going to happen is these 3 zeros are going to be to the right of the decimal, so I'm basically just going to drop those off, and you can write 5,300 as your answer. Okay? Top of the next. 6 and 72 thousandths is our factor here, and we're multiplying. And since we're multiplying by 10 cubed, it's going to be 1,000. That's 3 shifts. So when I shift these digits all to the left 3 times, 1, 2, 3, 6072 is your final answer. I usually don't put commas in. If you know me, then you know this is how I work. I don't put commas in for 4-digit numbers, but I do for 5 and up. It just helps me to read them. It'll help you to read them too. 10 to the 4th. Okay, that means it's going to be 4 shifts. Which way? Well, we're going to be shifting digits this way because it's multiplication. So again, think about place value. The 6 in the 10's place has to go shifting 4 positions over to the left. So you're going to end up with, and if you want to write it out again, 1, 2, 3, 4, you can do that. But the 4 here is telling you how many shifts. So you're going to go 100s, okay, that's the hundreds, then thousands, 10,000s, 100,000. So notice that I'm keeping count if you need to on your fingers in a place value chart, which we're trying to get away from because the objective for this is to, we're trying to reason, and it's always at the bottom of the page. Always look for that. Use exponents to name place value units and explain patterns. It doesn't say anything about a place value chart, so we're trying to get away from that. Anyhow, moving 4 positions to the left, and we're going to be in the 100,000s place. Remember that all the digits stick together. It's going to be 6072 all together, just like they are here. But if this is in the 100,000s position, you're going to have to add 2 zeros to the end in order to make it a whole number all the way to the 0. 10 cubed. 1, 2, 3. And I have 948. And now it's going to go to smaller place value positions because division tells me make it smaller. By how much? 3 positions. So I'm going to shift it all to the right until this is in the 10ths place. 9, 4, 8. Okay, 3 shifts. It's going to go from the hundreds to the 10s, 1s, 10ths. And finally, divided by 100, again shifting to a smaller place value position. 2 shifts. So from the 1s place, you're going to go 10ths, 100ths. 0.094. Okay. You should be able to explain all these to your teacher if you're not in my homeroom class. Now here we have patterns. So I want you to notice how many changes or shifts in the digits are happening each time. So if this one is 2 hundredths and then it goes 2 tenths, so that was a single shift left. It's almost like we're multiplying by 10 because it's getting a little bit bigger here. okay? You have to notice what the pattern is. If I was to multiply this by 10, I would get something here. What would that be? It would be 2. Then if I multiply that by 10, I'm trying to complete the pattern. Yes, that would work. So then each time for this row, or for each row, you're going to look for the pattern and see if you can figure out what comes next. If that 2 keeps shifting to the left each time, and it goes from the ones place to the tens place, what would be next? 2 in the hundreds place, and then 2 in the thousands place. Here we have a different pattern. We start out with 3,400,000, and then we're getting smaller. But it's not always just going to get smaller by one digit. So this is 3 million, but it ends up with 3 in the 10,000s. So it didn't go to the 100,000s. It skipped that and went to the next one. How many shifts? That's 2. They're getting smaller, so instead of multiplying, we're dividing. And instead of 1 shift, it's 2. So for each step here, we're dividing by 100, which means I'm going to get this number to be smaller by 2 place value positions for my next answer. So the 3 in the 10,000s place is not going to stop here. It's going to stop here in the hundreds place. 300, the 4 is next to it, and then 0. Then we have 3.4, again, 2 shifts. Excuse me, too much talking. 3.4, and then we need 2 more shifts, again continuing smaller. 1 shift would be to the tenths, but it's got to be 2, so it will be hundredths, 0.034. Next one. If I have numbers that are bigger here and smaller here, then as my numbers change, I am dividing. How many times do my digits shift? Try to find 2 that are next to each other and locate a digit that you can compare. If this one has 8 in the ones and this one has 8 in the tens, then if I'm going this way, I'm multiplying by 10 each time. If I'm going this way, I'm going to be dividing by 10 each time. So you can go either way. If it's easier for you to multiply and make the numbers bigger, then start here and move them over. If 8 in the tens place needs to get to be 8 in the hundreds place, you would then have 857 here. If you multiply it by 10 again, you get 8,570. If you multiply it by 10 again, you would have 8, 5, and then 5 in the thousands place, 700. Finally over here, remember if you're moving this way, because we have to know both directions, then I am making it smaller by 1 place value position. So divide by 10 and end up with the 0.857. Here we have 444. These 3 digits, it appears that because you can't tell the difference from all these, but now we have a 0, it appears that they all moved left or got greater by 1. So if I multiplied by 10, going this direction, that makes sense. Then I multiply by 10, and they move over again. So if I continue the pattern, we're going to multiply by 10, and instead of 44,000, it'll be 444,000. And then what? 4,440,000. There are only 3 4s in a row. 3 4s. That's all you keep, but you keep shifting the value. And again, finally, the biggest number, 44,400,000. Keep your 3 4s in a row and just fill in with the zeros until you get to the ones place, and that's the end. Finally here, we have small ones, 9 in the ones place, and then it goes 2 places bigger. Okay, so every time we go to the right, we're multiplying by 100 because it's a 2 position shift for that 9. So multiply by 100 every time you go this way. That means 9 in the 10,000s has to go 2 shifts over. That'll end up with 9 in the millions. The 5 is next to it, and then fill in your period so it looks appropriate with 3 digits in each period. From this one to the final line, we still have to multiply by 100. So 2 shifts from the 1 millions to the 100 millions. The 5 is next to it. The 0 has to go there. This is 100 millions. The thousands period has 3 zeros, and the units period has 3 zeros. Come back this way. If I have to find out where it was before I had multiplied, then I can divide this number by 100, and so I'm gonna have something that's smaller. So if I had 9 in the ones, but I have to find out what it was before I multiplied, then it's gonna go not the tenths but the hundredths. And so at the beginning it was 9 in the hundredths place. Then they multiplied by 100 and we got this. Then we multiplied by 100 and got that, and so on. Whew, that's a lot. That is a lot of stuff. Okay, on the back side. After a lesson on exponents, Tia went home and said to her mom, I learned that 10 to the 4th power, that's how you read that, is the same as 40,000. She has made a mistake. This is not correct in her thinking. Use words, numbers, or a place value chart to help Tia correct her mistake. So basically, write this down, 10 to the 4th. I want you to start with what is correct, okay? So this right here is 10 4 times. 10, 10, that's the 3rd. 10, that's the 4th. 1, 2, 3, 4. That's what that means, okay? So Tia made a little mistake. We don't have a 4 anywhere in our number. 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000. So she's trying to use the 4 as a factor, but we are not using exponents as factors. Exponents are not factors, okay? Don't make that mistake. To help Tia correct her mistake, we've got words, numbers, or a place value chart. You could probably do it a number of ways, but this is the way that makes the most sense to me. If you want to write words, I would say Tia needs to remember that exponents are not factors. Very, very important. Okay, so we're not multiplying 4 times the 1 at all, ever. We're just repeating that 10 4 times. Okay, next one. Solve 247 divided by 10 squared and 247 times 10 squared. Okay, so we're going to do both, but what is different about the two answers? We have to show, use words, numbers, or pictures to explain how the digits shift. So it's kind of easy if you use a place value chart and you just start with 247. Notice I have a lot of space between them because that helps me. There go the lights, but not totally because I have my sweet little lamp here. Okay, 247, and this is going to be where the decimal lives because this is the ones place, this is tens, this is hundreds. There you go. So 247 divided by 10 squared. Divided by means we're going to shift to the right. And 10 squared is equal to 100. So that means 2 shifts. It says right here, 2 shifts. So shifting, dividing, going to smaller place value positions. 2, 4, 1/10, 1/100th, label your place value positions, 7. Okay, so this is our first answer right here. Okay, so 247 divided by 10 squared is 2 and 47/100ths. But if I have 247 times 10 squared, multiplication, remember, is going to shift us off here to larger place value positions. Okay, So if I take my 247, let me rewrite it so you can see what's happening again directly beneath it. I have 247. And I'm going to multiply by 10 squared. So multiplying shifts numbers or digits this way. And 10 squared being the same 100. So it's going to be 2 shifts. This is 1, this is 2. 2, 4, 7. Now what about this right here? You have to fill in, because if you leave the 247 and you have nothing after it, well then it's blank and it looks like it's 247. But 247 when multiplied by 10 squared, it's going to be 100 times bigger. So you're going to have a big giant answer here, 24,700. So if I don't really have any room to explain, but if you wanted to write it out, you would have to talk about dividing shifts digits to the right for smaller answers, multiplying shifts digits to the left for larger answers. 10 squared is going to be 100 or 2 shifts either time. And finally, based on the answers from the pair of expressions above, the answers, okay, this answer and this one, solve 247 divided by 10 cubed and 247 times 10 cubed. So don't do any work is what they're saying. Just think about what would happen if you had to move an additional step. Okay? If you had to move an additional step, you would end up with the 2 being just one more spot. So it would be the 2 and the 4 and the 7 right here. Okay? So that's going to be for the first answer. Yes, I will usually hold this with a 0 just for consistency because that's what the book does. And for multiplying, if I have 247, we're going to have an additional shift to the next place value position. So instead of 24,000, you're going to get 247,000. And that would be your final answer here. And that's just based on what I did above. Okay? So I really hope you guys have it. I know it's kind of a tough lesson when they throw those exponents in. It's really hard. Anyway, click subscribe, come back again. I hope to see you on the next homework video. And remember, I do have problem set videos, super great for helping you learn. They've got some good notes with them. I'll see you on the next one. Bye for now.